In today's video, we'll be going over formal charge. Now, you may ask, what is formal charge? Well, formal charge is a charge assigned to the atom in a molecule. Now, typically in college classes, your professors, or in textbooks, you usually see this formula here, which is formal charge equals number of valence electrons minus half the unshared electrons minus shared electrons. Now, I can tell you that this formula is completely fine to use. However, for the sake of this video, I do have this other formula that I find very easier, and that is formal charge equals number of valence electrons minus the bonds plus dots. For the sake of this video, this is what we're going to be using. Now, I guess we can just go over some examples. Now, for this first example, we'll have methane. It's carbon, 4 hydrogens around it. This is methane. Now, we're going to use our handy formula, which is formal charge equals number of valence electrons minus the bonds plus dots. So, first let's look at how many valence electrons carbon has. This is the formal charge we're looking for that carbon in the middle. Now, to find the valence electrons, you're going to need your periodic table. So here, just write it out for you. CnOF, phosphorus, sulfur, chlorine, bromine, and iodine. This will be 4. I'm sorry, that one didn't come out so well. So this will be 4, this will be 5, this will be 6, and this will be 7. So as you see, carbon is in the 4th row. Column here. So that will be formal charge equals 4 minus, how many bonds are there? There is 1, 2, 3, 4. So 4 for the bonds, and how many dots do you see there? There are absolutely no dots, so that will be 0. So now what we have here is 4. 4 plus 0 is 4. 4 minus 4 equals 0. So the formal charge for the carbon of this methane is 0. Very straightforward, very simple, very, very simple. Let's do another example. Let's try nitrogen. So now we're going to find the formal charge of this nitrogen, and again, can use our handy formula. Valence electrons minus bonds plus dots. So let's see. Go over to your periodic table. Nitrogen has 5 valence electrons. How many bonds are there? We have 1, 2, 3, and 4. So that will be 4 plus dots, 0. Now you have 5 minus 4, which equals 1. So the formal charge of that nitrogen is positive 1. Alright, now let's go on to the next one. It's an interesting one here. Finally have some dots available. So what would be the formal charge of this molecule? Actually, I'm sorry, the atom, the nitrogen in this molecule. take a second to work it out. You can pause the video. We'll figure it out. So, again, formal charge equals valence electrons minus bonds plus dots. It's important that that formula becomes very repetitive. So when you're taking your test or you're doing your homework, this is in your head. Formal charge equals valence electrons minus the bonds plus dots. So let's see here. Nitrogen, again, like in the previous example, it has 5 valence electrons minus bonds, which is 2. How many dots? We have 1, 2, 3, and 4. We have 4 of them. Yes, so it'd be 2 plus 4. So now we have 5 minus 6. So the formal charge of the nitrogen is -1. Okay, now let's go into this next example. These are a few examples. We're going into interesting ones that might show up on your exam or test. So let's see, I have oxygen, hydrogen, double bond, and there. So now let's try to figure out what the formal charge of this molecule is. I'm sorry, I keep saying molecule. The oxygen atom. Later on in the video, we'll go over the overall formal charge of the molecule. But for now, let's just stick with just going at an atom. So, what is the formal charge? Again, guys should have this memorized already. Bonds plus dots. So, formal charge of oxygen, if you look on our periodic table, and again I'll write it out at the bottom here. HCNOF is usually how I memorize it. Kind of weird, but works. You have oxygen here, 6 valence electrons. So formal charge equals 6 minus how many bonds? We have 1, 2, 3. We have 3 plus dots. We have 2 small ones here. That's 2. 6 minus 5 equals 1. So the formal charge of this oxygen is plus 1. Very straightforward. Now, for this next example, we have this molecule. What is the formal charge of the nitrogen? I'm sorry, that's really bad. What is the formal charge of this nitrogen in the molecule? Now, again, we're going to use our formula. It's electrons minus the bonds plus dots. Nitrogen, in the third example, I believe, was 5 minus the bonds. Now, how many bonds are connected to this nitrogen? Well, it's actually 4. A lot of times, what they'll do in textbooks, practice problems, or even on exams is they won't draw out the bond for you between the nitrogen and the hydrogen. You have to kind of assume that it's there. So, in reality, this is what the molecule looks like. But of course, we all know in organic chemistry, sometimes they shorthand things. It's you just have to assume that there's a bond between that nitrogen and hydrogen. They assume that you know this. It sucks, but you know, there's ways that they try to trick you. So that is why the bonds in this molecule for nitrogen is 4. We have 1, 2, 3, and 4. Now, how many dots are there? You can see that there's 0. So now you have 5 minus 4 equals 1. So the formal charge of this nitrogen is plus 1. All right. Now, let's go into this next example. And in this example, we're going to figure out the overall charge of the whole molecule rather than just one atom in the molecule. So sulfur, we have 1 oxygen there and another oxygen at the end. So what is the formal charge here? Pause the video, think it over yourself, and we'll figure it out. Okay, so let's see. For sulfur, start with sulfur. We have formal charge equals valence electrons. Now, how many valence electrons does sulfur have? Well, it has 6 minus how many bonds? We have a lot here. We have 2, 3, 4, 5, and 6. So 6 minus 6. How many dots are on that sulfur? There is 0. So you have 6 minus 6 equals 0. So the formal charge for sulfur is 0. Now how about the 3 oxygens? For oxygen, we're not going to do each oxygen because you'll get the same formal charge for all of them anyway. So you have oxygen. Formal charge is the same as sulfur. If we look at if we did our periodic table again, CNOF 4, 5, 6, and 7. And under nitrogen, phosphorus. Under oxygen is sulfur, Cl, Br, and I for iodine. So oxygen has 6 valence electrons. How many bonds? 1 and 2. 1 and 2. Maybe 2. And how many dots? We have 1, 2, 3, and 4. Be 4. So now we have 6 minus 6, which equals 0. Formal charge for oxygen is 0. And we're not going to do the other oxygens because the other oxygens have the same amount of bonds and dots as this first oxygen. Therefore, for this oxygen it would be 0, and this for this oxygen it would be 0. This one is 0, and we said that sulfur is 0. So what is the overall formal charge? The overall formal charge would be 0. Okay? Let's go over about 2 more. Okay? Let's go over this one. We have a double bond, oxygen, 2 dots, nitrogen, oxygen here, boom. Okay, so let's piece this together. I guess we'll start with this oxygen here. We'll call this O1, so O sub 1. So the formal charge equals valence electrons. How many valence electrons is in oxygen? Well, for oxygen we have 6. How many, minus the bonds, how many bonds does it have? 1 and 2. So 2 plus the dots, 1, 2, 3, and 4. 6 minus 6, because 2 plus 4 is 6, equals 0. Formal charge of the first oxygen is 0. Now let's talk about this oxygen to the bottom left. We'll call that O2. We have the formal charge, which equals 6 again, minus the bonds. There's only one bond here, only one. So we have 1, and then we have 6 dots. We have 1, 2, 3, 4, 5, and 6. So now what do we have? We have a formal charge equals 6 minus 6 plus 1 is 7. That gives you a negative number. So the formal charge of the second oxygen is -1. Let's go to this oxygen to the right, the bottom right. We'll call that O sub 3. Formal charge equals valence electrons. Oxygen has 6, just like the others, minus the bonds, which is 1. And then the dots, 1, 2, 3, 4, 5, 6. Plus 6. And just like the second oxygen, get a formal charge is equal to -1. Okay. Now for the last one, we'll go over to the nitrogen. And we have, for the nitrogen, formal charge equals 5, because it has 5 valence electrons, minus the bonds, has 1, 2, 3, and 4. So it'll be 5 minus 4, and how many dots does it have? It has 0. So now we have 5 minus 4, and that is 1. So now to find the formal charge, you're going to add up all of these formal charges that we got for each atom. 1, -1, -1, and 0. You have -1, and -1 is -2, plus 0, still -2, and -2 and 1 gives you -1. So now the overall charge of this molecule, see if we have space there. Typically you'll see it written like this in a bracket, is -1. So the overall charge of that molecule is -1. Okay, and let's just go over one last one, and it should conclude this video. Okay, this is a fairly simple one, but it usually shows up. Let's see, so for this carbon, how many valence electrons are in that? 4 minus how many bonds? 1, 2, 3. So that's 3. How many dots? There are 2. 4 minus 5 equals negative 1. Formal charge of this carbon is negative 1. Now for the oxygen, we have the formal charge equals, you just write it under here for more space, valence electron 6 minus the bonds, same as the carbon, 1, 2, and 3. So we have 3 bonds plus dots 2. So now we have 6 minus 5, which equals 1. And if we take a total of these two formal charges, you get 0. So the overall charge of this molecule is 0. And this concludes the video for today. Just remember, formal charge equals valence electrons minus bonds plus dots. And if things are written in another way, like in the other example where I said you have the N and H but they don't show the bond, just assume that it's there. Otherwise, this is a very great method for you to use. You'll see it on, you can use it on tests, textbooks. You could use the other example as well and you'll get the same answer, okay? So this concludes this video. Thank you. Like, comment, and subscribe. You can ask any questions if you like. And I'll see you next video.